So I think I'll start by talking a little bit about what Vinted is as a company. So Vinted is Europe's largest second-hand marketplace where ordinary people like you and me can take things and stuff once loved that's now in the corner grabbing dust and put it online on a platform for others to sell. So you can make a little bit of money and you can give old stuff a new life. So it's a win-win situation. And with that, our mission is to make secondhand first choice worldwide. So how are we doing on this mission? We are based in Europe, a European company. We are active in over 20 countries, and we have millions of registered members. We are over 2,000 talents even. A couple of them are sitting in front of me. Hi guys, thank you for joining. We're scattered over 10 workplaces. Vinted at its core is a data-driven company. So you can imagine with millions of registered members, we have millions of transactions on a weekly basis. So there's quite a lot of data flowing through the pipelines. So in order to handle all that data and turn it into meaningful metrics, we decided to take, it's 10% of those 2,000 talents that work in the data landscape, and we decided to split them up into separate teams. I think this is a common practice in a company, right? What we find is challenging in such a setup is that quite quickly, teams will require each other's data, right? So for instance, finance might need a little bit of everything from everyone to understand the health of the company, how the company is doing. Supply team might need something from network and so on and so forth. And before you know it, you have a very intricate spider web of dependencies between teams. And in order to stay ahead of our growth and scale, we decided to create a setup where we decentralize these teams. So each of these teams have their own repository with their own deployments so that they can work autonomously, make decisions fast, and keep ahead of the growth. So let's have a look at what one of those teams looks like. So we have within a team, each team owns their own DAGs. And these DAGs could consist of DBT tasks, so they do transformations. They might do some model predictions with Vertex-AI. They might run some batch processing with Spark and some custom code using containers. But what happens is if you work in a decentralized setup is that you lose the context of the teams around you. So it could be that you need some assets from other teams, but now suddenly you don't really know where they're coming from, could be in multiple places, and it works both ways. So who's using my assets? It suddenly becomes quite unclear. So basically when we zoom out again, what the challenge was for us is how do we deal with these arrows between the teams? So how do we create clear dependencies, keep the communication at a minimum, so that we can maintain that isolation, so that teams can move fast, we don't have a million meetings if you want to make a decision, and we can stay ahead of the growth. So basically to sum up our situation, we are started with a centralized setup, decided to decentralize, but now we're in a situation where it's harder to coordinate things, so we need to decentralize a little, like this little guy in the bottom right is tugging his life for. So how do we do that? I want you to recall the setup I showed of the decentralized teams and consider that each of these teams is a part of a larger puzzle. So what we've created is a code generator. We still haven't decided what the logo will be, so this will have to do for now. But if you have suggestions, please do come find us after. And what this generator does is it molds these pieces of the puzzle such that they perfectly fit next to one another. And we give those pieces to Airflow to then connect the dots and put them together and create this big puzzle. So if you would buy or if you would see the box of this puzzle to give you an idea of the scale we're working at, we have about 150 DAGs running 20,000 tasks a day. So for us, the complexity really lies within the DAGs because the teams, they own their DAGs and they can become quite large. And my colleague Rodrigo will tell you a bit more about how this code generator lays this puzzle.
Thank you, Oscar. So I'm going to show you a little bit how the interface for the users work and example PR also to see a little bit how when you are actually doing work, you don't need to touch anything Airflow Python code, and it makes things a little bit easier. But I'm also going to focus on how we connect these different tasks that Oscar showed. So if we have a DAG like this, where we have multiple things, or maybe more expanded, where the task groups have different tasks inside, how do we connect this? Well, not we, but how the users define these connections. We have a simple boring YAML file where you have some versioning, some alerting, who owns what, where to send the warnings if you have some, and the DBT settings that tell us if you are using DBT or not. So with this setting, you can define if you want to expand the DBT tasks, and it will generate these individual nodes, a little bit like Cosmos, but with our little tricks. And then we have another part that are the other tasks that Oscar presented, where we have kinds, so universal, vertex, you name it. We have conditions that are things that you're waiting for, so assets that you're waiting for, and assets that you're producing. So a little bit like the outlets that our previous presenter showed. And then we have this part that tell what of these assets can be used outside your team in these connections that Oscar showed, and also establish which is the SLO. So we need to have some contracts. We need to know that we cannot wait forever. So we have some timeouts that are gonna be there declared. And then to go through this connection where we have a DBT thing that then goes to Vertex-AI and then goes back to DBT, how it looks like? Well, you have the DBT model YAML. If you use DBT, you will be quite familiarized with that. That you are saying that, okay, my input DBT model has a pipeline that in this case is hourly. We have fixed pipelines, so the dependencies are easy to track. And then when you have another task like the Vertex-AI, you just put input DBT model, the name, and that's it. That's connected. You put what is being produced by that Vertex-AI task, and you end up with a source in DBT. So if you work with DBT also, you will see this, and you will be that, you declare a source, you have it there, you name it in a model, and that's connected. So we end up with that connection. What about the lines, right? We had this situation that we have external things. I show you how to connect internal things. Now we need to know how we connect those external things. Well, it's easy. We add a new task group that it's hard dependencies or soft dependencies, if you have those, that are basically Airflow sensors that connect with other teams' DAGs. And if you remember, in the scheduler YAML file, very good name, very clear, you have the exposed assets. So we know that all the dimensions in this case that are daily will have an SLO, and that SLO will be the timeout that you have in the sensor. And we're gonna come back to this a little bit when Oscar shows you how we do the alerting and why this is important to coordinate these different communications without actually speaking to your teammates in other teams, which is very good for working fast. So when you declare that, we generate a JSON file that goes to a bucket with this information: where is the task running, DAG, task group, task ID, everything that you need to create a sensor. And later on in CI/CD, when you use that, so you say, I'm using a global asset, name, mention customers or whatever, we validate that that exists, that someone declared that that exists and that you have an SLO for that and that is running somewhere. So that way we create a contract. And at the end, it's a source like any other in DBT. If you want to use it in a other type of task, then you can also declare it as an asset, and it's a global asset in this case. Okay, I show you all this YAML file, but once that you configure this the first time and you have your things more or less working, what about I want to add a new model that it's this fact shipments thing that uses something from somewhere. So I'm adding a new global dependency and creating a new model. So that's the PR. You only do that. you have a nice message in our CI/CD that tells us like, hey, yeah, we are creating this new task. We are creating this new global dependency. Everything is validated, and you are not breaking anything downstream. Because you could also say like, oh, well, my test users dimension, whatever, now I want to run it daily because it was very expensive being hourly. So if you change that, you get a message and it will tell you, hey, please send a message to this channel and tell our guys that you're gonna be changing something that might be not very convenient for them. So we have the CI/CD validation, you merge your PR, everything is fine, and automatically on deployment, you end up with your new Mart, and you're waiting for dependencies. And like that, you can just develop DBT. You don't need to think about Airflow. You don't need to think about debugging. If the sensor this, I need to wait for that or whatever. You just write DBT code or Vertex-AI pipelines, and we take care of the rest.
So with that, some of you might ask or wonder, all these wonderful presentations about assets, data sets, why in this case go for a sensor setup? So let's have a bit of a deep dive into why we chose this specific setup. So if I take you back to this puzzle box I showed you, there are about 150 DAGs running 20,000 tasks. So the complexity really is within the DAGs. And teams, they need each other's assets. So before, it could be that this red team might be producing some assets that are used by the purple, orange, or yellow teams. In turn, the yellow teams could be having some dependencies with the green ones, and this goes on and on. So basically what we're looking at is what we do is create one big DAG that is neatly split into smaller DAGs based by ownership. And these teams then don't need to necessarily have the full context of what the other teams are doing. So it is our job to make sure that these black lines work seamless, to ensure that it stays like this and they can focus on their own parts. But if we zoom into this part at the bottom, a problem arises. So when we have a look, the first thing that you might think of is this looks awfully lot like a circular dependency. And I think all of us at this conference are allergic to circular dependencies. But if you have a closer look, you'll find that if you look at the task level, there is no circular dependency. You can follow the lines and it will finish just fine. However, on a DAG level, it does exist. So if we were to use assets that have outlets on tasks, but can only trigger DAGs, we would have to saw this DAG in half, ending up in a situation like this. But recall that Rodrigo showed you that people don't work with Airflow. They create new DBT models and introduce dependencies. So they do that, they run their PR, they deploy, and all of a sudden they have two DAGs. And they don't understand why, because they don't necessarily have the context of the green team. So we suspect that the reaction would look a little bit like this confused man that we are all aware of, or that we all know. But it doesn't stop there. If we go back to this image, and you specifically look at the first two tasks of the green team, these have no upstream dependencies. So they would be waiting for tasks by the yellow team, but they don't have to. And in this example, this may not look like a problem, but if we go to a more real-world scenario, something like this, suddenly there are a lot of tasks waiting for no good reason. And the problem gets bigger if the task in the yellow DAG fails, because then the whole green DAG doesn't even start. And if you look a bit closer, you'll see that the bottom part of it, there's a full lineage that doesn't even connect to this dependency. So what we can do with our sensor setup is that we handle dependencies on a task level, which means that this situation would look a little bit more like this, which is what we want. Just the parts that are connected or have upstream dependencies should wait until the task completes. So everything that's connected, business operations, dashboards, you name it, on the bottom part of the lineage, they're fine, no problem. What the sensor setup also enables us is this alerting that Rodrigo mentioned. So let's go through one of those real-world situations where in a DAG of the supply team, there may be a problem, an error of some sort. So first of all, the first thing we want to do is let them know and give them an alert with an error severity, like stop what you're doing, focus on this, fix it. But recall that we still have connections between the DAGs, right? So there may be dependencies in the other teams on this specific task. So now that we have this sensor set up, we can specify that this is a different type of task, a sensor task. We're sensing something upstream that is owned by a different team. So we can create alerts, but now notify on a warning level. So these teams know that their downstream from this sensor is not going to build, not going to complete, but it is not their responsibility to take immediate action. So this saves a lot of time in understanding what went wrong. Why is my data not fresh? But there is a weakness in the sensor setup. So we do like the datasets and assets, and we took inspiration from them because a sensor polls for the duration of the timeout, the duration of the SLO. And once it is breached and this warning fires, the sensor has failed. It's not going to poll again. So what we created, what would happen if this is fixed, then it doesn't necessarily continue the downstream processes because the sensor has already failed. So what we've done through the asset registries, we created a callback where we can utilize this asset registry and understand where are the tasks that are depending on this specific task that's just been fixed. And we go through them one by one. And we clear them, we mark the sensor as success, so automatically the DAG continues. So we sort of mimic dataset asset behavior on a task level. And then Rodrigo will take it away and discuss what the new normal looks like.
Thank you, Oscar. Yeah, well, the new normal, the old normal, we didn't show it very well, but the new normal is very nice. Before, we were in a sort of a Wild West with the teams there. They were kind of fighting a little bit, and the data platform sheriff was very sad. This is Oscar, like with all those teams. So we created this generator, we standardized some things, we brought progress, and now we have something like this, like a little congress where we are more civilized with our contracts, and where we have like this alerting mechanism that tell us, yeah, okay, well, I can help you. I don't want to help you now. I don't have time, but I understand. So they start to communicate in a different way, and we also are starting to discuss where are the bottlenecks? How can we make this better? Because we know those dependencies. We can track where are things that are failing. We can also see our big data model across all these teams, how it's performing. So we have quite nice metrics about that. And also something that is very good is that we created a user interface that is not coupled to anything that happens in the code. So if we need to upgrade to Airflow 3.0, we actually kind of already did it in 2 days. Yeah, so we did it in 2 days, but we didn't push it to production yet because we need to get our users first acknowledged with this. So we came all here, and now we're gonna do it when they're back. And imagine this situation where every puzzle piece is different. They are from different boxes, and then you're like, okay, well, this is very, very complicated to do. Also, you have people with different expertise. They probably are using LLMs, and if you are not good at prompting, you're gonna get Airflow 1 suggestions to write your DAGs, and yeah, it gets very, very intricate. So with the DAG generator, this is easy. They don't need to change anything. They don't need to care about it. We can upgrade things. We can also add different tasks if we want at the beginning or at the end for observability, for things that we want to apply to all the teams at the same time. So this unlocked a lot of things that before require a lot of coordination. And now we have the coordination, but it's way, way easier. And with that, we close.